Hey guys, this video is going to go over adding and subtracting polynomials. All right, so first thing that we have to know before we can get into the main part of the lesson is you guys need to know a couple of vocab words that we did see earlier in the year, but I just want to give you a quick refresher. So first thing, when we work in math, there are things called expressions. An expression is basically just like a math sentence without an equal sign. So this is an expression. This is actually called a quadratic expression, this one up here, because it's got this x squared term. But this is an expression. 5x, that's an expression. 5x plus 4, that's an expression. 4 plus 3, those are all expressions. So basically a little math sentence without an equal sign. All right, now there are different types of expressions that we can name or kind of classify. So the first type is called a monomial, and a monomial is an expression that only has one term. So like 5x, that's a monomial. 3x squared, monomial. Just a 5, monomial. It just has one term, an expression with one term. Now a binomial, you might notice the little prefix here is bi, usually means 2. It's an expression with 2 terms. So a binomial example would be like 5x plus 4, or x squared minus 7x. Those are binomials because they have 2 terms. And then a trinomial, pretty easy, you guys probably can figure this out. Tri usually means 3, so it's an expression with 3 terms. An example of a trinomial would be like x squared plus 3x plus 4. Okay, it's got 3 terms in it. All right, so our next vocab word kind of goes back to those ones we just learned. There's something called a polynomial in math. And basically all that is if you take a monomial, so maybe just like 5x, and then just that by itself, that's called a polynomial, or if you add another monomial with it. So if I added like, let's say x squared, that's another monomial just by itself. This is a polynomial now, okay? It actually has 2 terms, so I actually can classify it as a binomial. Okay, so again, a polynomial is just if I take like a monomial and now I add some more to it. So if I put a plus sign and add another one to it, like 8x, now that's a binomial, but it's also a polynomial. Well, I know it's kind of a little bit confusing. Okay, so you can also classify a polynomial by its degree. Now, this is another little confusing thing, but the degree of a polynomial is the degree of the term of the polynomial with the greatest degree. Okay, so let's look at this first one here. So basically all you do is when you have a polynomial like this is you look at the exponents. Okay, so look at this one. This one has a squared. This one doesn't have an exponent. So this is the term with the greatest degree. So they call the degree of that polynomial the second degree. Okay, this one, it's got a 2 and a 4. If I add that together, it's 6. This one just has a 5. This one doesn't have one. So this is the one with the greatest degree, and the degree would be the 6th degree. Okay, this one back here. This one's got a 3 for a power and a 4. That's a 7. This one has a 7. And when I have this exponent or this variable, there's really a 1 right there. Okay, I'll just put 1 up there, 1 right there. So this one would be to the 8th degree. We're not going to do too much with that, but you just need to have seen this before. So I just wanted to give you a quick view of what that means. All right, so the point of showing you how to find the degree of a polynomial is so that we can write it in standard form. So we write polynomials in standard form so that we kind of have them in the same order. Otherwise, when you have really long polynomials, it's hard to check them unless you put them in the same order. So what you do to put them in the correct order is you look at their degree. That's why we use that. So like if I had this one, 4x cubed plus 5x squared y to the 5th. If I look at this one has a bigger degree. 2 and 5 is 7. So I want to put that one first. Then I'm going to list my next one, 4x cubed. Okay, so let's look at this top example here. Okay, I've got 4x plus 2x squared cubed minus 8 minus x squared. So I'm going to look for the biggest degree. Well, my biggest degree, it looks like, is the cubed here. So I'm going to start with 2x cubed. Okay, I use that one. My next greatest exponent is this x squared, so minus x squared. Okay, my next one is 4x, because there's really a 1 by that x, so plus 4x. And then my constant term, which is minus 8. Now I put that, this is called standard form. Okay, one other thing that kind of shows up in this chapter is there's something called a leading coefficient. All that is the number part of the first term of the polynomial. So here's my first term right here. The number part of that is the 2. So that's called the leading coefficient. All right, let's look at the second one then. All right, in the second one, I see this is the biggest one, the 6. So they listed that first. Then the cubed would come next. Then the x, because that's to the first, would come next. And finally, your constant term 3. And then that's now in standard form. And then your leading coefficient is the first number in the first term. So your constant number, which is -7, that's called the leading coefficient. All right, let's pause the video and see if we kind of understood that vocab, because I know that was kind of a lot. So it says, write each polynomial in standard form and identify the leading coefficient. All right, so if I look at this one, if you guys want to pause this and try it on your own first, that would be great. But if I look at this one, I know the 4th is the biggest degree, so I'm going to start with that, and it has a negative sign in front of it, so I'm going to write -x to the 4th. My next one is going to be the squared, so plus 3x squared, because that's the next highest power, and then I have the plus 1. That is standard form, and then the leading coefficient is where you need to look at the, in the first term, that number part. Well, there's not a number there, but that really is a -1. So that's my leading coefficient there, is -1. Okay, let's look at number 2. Okay, it looks like the highest degree or power is 6x to the 3rd because of that third power. Then it looks like the squared, so plus 3x squared. Then it looks like plus 4x, and then finally plus 1. Okay, the leading coefficient would be this first term, would be the 6. That's the leading coefficient. All right, let's look at number 3. It says identify the type of polynomial and the degree of it. Okay, so the type would be, is it like a binomial or a trinomial? Well, this one has 3 terms, so it's a trinomial. Okay, and then the degree of the polynomial. Okay, it looks like I've got a 1 here, 1 here, 1 here, so it looks like it would be, okay, so you go to the term with the greatest degree, which would be this one right here, because it's got 2 exponents, so it would be the second degree. Oops. Okay, let's look at number 4. Okay, so if you guys look at this one, it looks like it's a binomial because it's got two terms. And then this one, if I'm figuring out the degrees, this one's to the 5th degree, this one's just to the 2nd, so it would be a 5th degree polynomial. And again, I got that from this one here. That was the higher one. All right, so real quick, today we're going to be learning how to add polynomials, and in order to do that, you have to be able to recognize like terms and unlike terms. Now, we have done this before, so I just want you to look through these examples. These are like terms. They have the same variable. If they're like terms, you can combine them. So like 2x plus 3x is 5x if I was doing an addition problem. These are also like terms because they have the exact same x squared y. So total, if I was going to add them, would be 9x squared y. Okay, here, these I can also add together because they both have a squared b squared. Even though it's in a different order, they both have a squared b squared. Total, I see 5 of those, 5a squared b squared. So again, I can combine those. So like terms you can combine. Now, unlike terms, you cannot combine because they do not have the same variables. So 2x and 3z, I can't combine them, but I could write an addition problem. 2x plus 3z. Now I just wrote a binomial. Okay, same thing here. X squared y squared and z squared x squared, not the same. Okay, but I could write an addition problem. X squared y squared plus 4z squared x squared. Okay, and again, I just wrote a binomial. So we're going to use that when we learn how to add polynomials. All right, so we are going to start by learning how you can add polynomials. So we're going to start with that, and I'm going to show you 2 different ways to add polynomials. And once you see this, it's really quite easy, but I'll just show you. So we have one polynomial, 3x squared minus 7x plus 2 plus another polynomial. Now, you guys know when you're adding, it does not matter the order you add in. So all I'm going to do, the adding's real easy, is combine like terms. So I see a 3x squared and a negative x squared. Those are like terms. I'm going to combine them, and I end up with 2x squared. Okay, I'm going to find some more like terms. I'll just highlight it a different color. I see a negative 7x, and I see a 4x. Okay, that would give me a negative 3x together. So I'm going to write minus 3x. And then I see a 2, I'll just do my normal numbers, and a 5. If I add those together, I get a 7. Okay, so I just added that polynomial together. Basically just combining like terms. Now, I did put it in standard form, okay, because you can see the greatest degree went first, and then the next one, and then the constant term. All right, now another way that our curriculum shows us to do this is called the vertical format. So here's what you can do. You can actually write like an addition problem going up and down. So I'm going to write the top one, 3x squared minus 7x plus 2. Okay, I'm going to write it an addition problem, kind of like this when you first learn how to add. The only thing I have to be careful about is putting them in the right order. So here I have a 4x. I'm going to put that right below here, and it's positive. Here I have a plus 5, so I'll put that below my other constant term. And then here I have a negative x squared. I'm going to line that up with the other x squared. So you just basically have to line up your like terms. I can put a plus right here too. Okay, now you just can add kind of going up and down. So here, 2 plus 5, that gives me 7 plus negative 4x, or negative 7x plus 4x is negative 3x. And then 3x squared plus negative x squared is 2x squared. So I end up with the same thing. One way I just did it horizontally. That was the first way I did it, and combined like terms. The second way I did it going up and down, which is called vertical format. All right, so just one more quick addition one, and then you'll learn about subtraction in your next video. So I'll just do this one using the vertical format. Again, you can choose, it does not really matter. So I'm just going to use the vertical format. So I'm going to start by writing 8x squared y plus 4x squared plus 2. Okay, so I took care of that one. Okay, then I see a negative 10x squared y, so I can line that up right below the 8. Okay, now plus y squared. Now I don't see that anywhere, so I'm just going to have to kind of put that on the back here. And then I see a plus 8. Okay, now there's a couple blank spots I need to fill in on one like this. There are no x squareds here, so you can just leave that blank, and there are no y squares here. You can just put a 0, whatever you kind of want there. So when I add this up going vertically, I get y squared here. I get 10 here. I get 4x squared here, and then I get negative 2x squared y. Okay, now only thing you have to do at the final part of this is you need to write this in standard form. So the greatest degree would be this one. So I'm just going to come write it up here, negative 2x squared y. Okay, the next greatest degree would be, these both have squareds, so then I'm going to go alphabetical. I'm going to go plus 4x squared, plus the y squared, and then plus the 10. And there is my final answer in standard form. So tomorrow we're going to get into subtracting, and then we're going to be getting into some application problems with this as well.